In intralogistics, we distinguish primarily between bulk goods, often handled as continuous flows, and discrete goods, which are managed and moved as individual units or unit loads. Let's begin with bulk goods. Examples include sand, grain, or minerals stored loose behind containment walls or in silos. These materials flow under gravity or are conveyed pneumatically and typically require equipment such as belt conveyors, screw conveyors, hoppers, and storage silos. In principle, bulk goods can be converted into discrete units through packaging, for example bagging flour or sugar. But until they are encased, they pose different challenges than discrete items. On the right side, we see discrete goods, packaged items like cartons, boxes, or crates that can be handled individually or in unit loads. These goods normally can be identified, for instance with the help of barcodes or RFID. Our course focuses on discrete goods and will touch upon bulk goods only to the extent they are turned into discrete goods through packaging. The key takeaway from this slide, bulk versus discrete, is the foundational distinction. Automation for bulk goods emphasizes flow control and storage volume, while automation for discrete goods focuses on unit handling, identification, and precision placement. You might ask, what about liquids or gases? On the left, we see a gas pipeline network, an infrastructure for continuous pressurized flow. Similarly, liquids in the chemical or food industries travel through pipes, pumps, and tanks, not across traditional conveyor belts or racks. Automation here centers on valves, flow meters, and robotics for filling or sampling. However, even gases and liquids can appear as discrete load units when packaged. On the lower right, notice gas cylinders. These are individual portable containers that must be moved, stored, and tracked, just like any other discrete good. They require dedicated racks, handling trolleys, and safety measures for pressure vessels. Functions of packaging. In most cases, our logistical flow units are not bare products, but packaged products. Packaging serves a number of different purposes. What are the functions of packaging? Actually, there are quite a few. Some are obvious, some less so. Let's discuss them. Let's start with one of the most obvious but critical functions: protection and containment. Packaging protects the product throughout the logistics process, from the production site to the final point of use. During transportation and storage, products can be exposed to a variety of risks, including shock, vibration, temperature changes, humidity, and sunlight. A good package forms a barrier that shields the product from these external influences. But protection is not only about physical impacts, it's also about preventing contamination, especially in sectors like food, pharmaceuticals, and electronics. Packaging keeps unwanted substances out and the product's integrity intact. In some cases, it also helps with theft prevention. Tamper-evident seals or opaque packaging can deter manipulation or unauthorized access. And finally, containment means keeping everything together. This is particularly important for products made up of multiple small parts. Think of an assembly kit. Without proper containment, parts might get lost, damaged, or mixed up during transit. So, protection and containment are foundational to preserving the product's value and usability. Now let's move on to the second major function, handling and storage. Or, more generally, what we could also call stabilization and unitization. Efficient logistics relies heavily on standardization. Packaging plays a key role here by shaping and sizing products in a consistent way. Packaging makes it easier to grab, lift, and transport them. This applies to both manual handling and automation. For example, when items move on conveyors or are handled by robotic systems. In addition, standardized packaging allows for efficient stacking and maximizes space usage in storage systems and transport vehicles. When all units fit well together, like boxes on a pallet or cartons in a shelf, we avoid wasted space and reduce the risk of damage. Most importantly, standardized packaging enables the use of standardized load carriers like pallets, totes, and containers. This, in turn, allows for a streamlined design and operation of the warehouse. Material flow systems, storage racks, and conveyors can all be optimized around these standardized dimensions. So in summary, while protection keeps the product safe, stabilization and unitization enable efficient logistics processes. Together, these functions make packaging not just a container, but an enabler of efficient logistics. Continuing with the functions of packaging, let's now talk about two functions that are particularly relevant at the interface between logistics and the market: the information function and the marketing and branding function. Let's begin with the information function. Packaging is often the first and most direct carrier of information about a product. This information is not only important for consumers, it is also highly relevant for retailers and logistics providers. Packaging may display product specifications, ingredients, country of origin, manufacturer or batch number, handling instructions, and, in many cases, safety warnings. From a logistics perspective, this information can be critical. For example, let's consider a warehouse storing chemicals or pharmaceuticals. Knowing whether a product is flammable, temperature sensitive, or hazardous determines how and where it can be stored. The same applies to transportation. Packaging must clearly indicate whether a shipment must be kept upright, protected from sunlight, or handled with care. In cold chains, labels may indicate minimum and maximum temperatures. So even though this function may seem like a regulatory or consumer-related detail, it has very practical consequences for logistics operations. In fact, failing to display correct information on packaging can lead to storage violations, transportation errors, or even safety incidents. Now let's turn to the marketing and branding function. Packaging is a key element of how a product is presented to the customer. In the context of retail, especially in fast-moving consumer goods, FMCG or e-commerce, the packaging is part of the product's identity. Colors, logos, shapes, and materials. All of these are used to create brand recognition and differentiation. Think of Coca-Cola bottles, Apple boxes, or luxury perfume packaging. The design is not only meant to protect the product, but to create a specific customer experience. From a logistics standpoint, however, this can cause problems. Why? Because packaging that is optimized for marketing is often not optimized for logistics. We frequently see unusual shapes that are difficult to stack, excessive empty space within packages, or materials that are fragile or incompatible with standard handling systems. This results in inefficient use of space, higher damage rates, and additional costs for repacking or special handling. So, while marketing and branding are legitimate business priorities, they often conflict with the goals of efficient storage and transportation. In short, the information function of packaging supports operational safety and compliance. The marketing function supports sales, but may work against logistics efficiency. Balancing these goals is a classic example of the interface between marketing and logistics. A key topic in supply network design, and a frequent point of conflict between the two functions. A practical case: Amazon's frustration-free packaging. Amazon recognized this issue more than a decade ago. Many products sold on its platform were delivered in retail-optimized packaging, attractive, but inefficient and often frustrating to open. This caused frequent complaints, waste, and inefficiencies in fulfillment. In response, Amazon launched its Frustration-Free Packaging FFP initiative in 2008. They may have dropped the name along the way, but that's how it was called in the beginning, and the goal has remained the same. Design packaging that is easy to open, made from 100% recyclable materials, and optimized for logistics, meaning minimal dimensions, high stackability, and reduced damage risk. Suppliers participating in this program must ensure that products arrive in packaging suitable for direct shipment to the customer, without requiring Amazon to rebox or reinforce them. This initiative had multiple benefits: improved customer satisfaction, reduced packaging waste, lower shipping costs, and faster processing in Amazon's fulfillment centers.